Good afternoon. My name is Paul Fernandes. I'm at the School of Biological Sciences at the University of Aberdeen, and I'm a fisheries scientist. So that's a marine biologist that concentrates on fish and fisheries, commercial fisheries mostly. And I've been working in that field for about 30 years, initially in government departments, latterly in the Scottish government, where I was at Marine Scotland Science for 17 years, initially working on surveys of fish stocks and then what are called stock assessments of fish stocks. And all of this led to how we assess quotas and essentially how we manage our fisheries sustainably. And since coming to the university almost 10 years ago now, I've developed a research program along those lines. And so much of my work still focuses on the sustainable management of our fisheries resources. But in the wider context, that includes elements of marine ecology, looking at our fisheries ecosystems, and in particular looking at methodological development and various ways of improving management. And today, I'm going to talk to you about a few of those things, some work we've been doing looking at how fish distributions have been changing. And that's led us to think about some of the challenges associated with how we manage fisheries in Europe. This work has been funded by the European Commission and also received some seed funding from the Scottish Fishermen's Federation, and I'd like to acknowledge them in their support of the work. The work is detailed in 2 articles which you can access for free, because they are open access. These are the primary literature that's the subject of what I'm about to talk about. First one appeared earlier this year in a journal called Ecography, and you can see the DOI in there. And the second one was in a journal called Conservation Letters, and that's the DOI there. These are searchable under Google Scholar, under my name with fish distributions, for example, or by accessing that DOI link directly. But you can read the details of what I'm about to speak to in both of those papers for free. Like I say, they are open access. The context for this is how we manage our fish stocks, and I should start by talking about the range of fish stocks that occur in the Northeast Atlantic. This is the area I'm considering, Northern Europe, so it doesn't include the Mediterranean. And on the left-hand side here, you see a map. And each of these circles represents a fish stock, and a fish stock is a particular species in a particular area. So, for example, you'll see cod in the North Sea, it's a big red dot here, and there's another cod stock on the west of Scotland, another one in the Irish Sea, etc. So you have multiple examples of the same species, but different stocks of that species, and there's obviously lots of different species. Now, what I've color-coded here is the status of those stocks in relation to their sustainability. And the red dots are stocks that were overfished. Their harvest rate, this delta H, was excessive by a certain proportion over the amount it should be. So that is the proportion that is removed each year. And the green dots are the sustainable fish stocks, and they're the ones that are fished at sustainable levels or less. And this is the picture that was in 2002. This is a publication that we produced in 2013, looking at a retrospective of how our fish stocks were doing. And in 2002, most of those fish stocks, as you can see, are red dots, and they're big red dots, which means that they were excessively fished, and they were all overfished, the red being overfished. However, by the time it came along to 2011, 2 years before our published study, the situation had changed quite considerably. You can now see that most of those dots are now green, and this was the year when they crossed the threshold from the majority of stocks being not overfished, being underfished, in fact, and in some cases quite largely underfished. And you see these large green dots. There's still some fish stocks that are overfished, the red ones, in particular the cod stocks of the North Sea, Irish Sea and west of Scotland, and some of those can be quite high. But you can see that not only has the colours switched, but the red dots have become smaller, which means that they are closer to sustainable levels. So essentially what these 2 pictures tell us is that these fish stocks are recovering because our exploitation on them has reduced. And as a result of that, we have seen some recoveries in the population. Here's two examples of that: North Sea Place and Northern Hake, which is a stock that occurs in the North Sea and the Celtic Seas. And what we're going to look at here is the biomass of the adults, which is called the spawning stock biomass, and see how that's changed over time. And you can see back in the 1980s and 90s, when the fishing pressure was high, the biomass was low. And in the last 10 years, since about 2010, associated with the picture on the left, which shows underfishing or fishing at sustainable levels, we have seen that as soon as we get control of exploitation and the overfishing stops, these populations can recover, and can recover quite drastically. We're looking at orders of magnitude in one case potentially, and multiple scales of population increase of 5 times in the case of Northern Hake. So a big recovery in these populations. Now, let's have a look at Northern Hake. Here's another paper that we published back in 2015 looking at the case of Northern Hake, because that's interesting. As the population recovers, it occupies more space. Back in 2001, when the population was at a low level, hake was restricted to its traditional, so we say, areas to the west of the British Isles and into the Bay of Biscay, and very little of it occurred in the North Sea. However, by the time 2010 came along, when the population was well on the way to recovery, hake had expanded its distribution and was now spilling into the northern areas, and in particular the North Sea. So on the left-hand side now you see these dots, which are catch rates of hake from trawl surveys, and we're now seeing very large amounts of hake in the North Sea associated with this population recovery. And this is occurring for a number of species, and it's occurring for those reasons, but also because of the effect of our climate. And here's a rather complex picture, which is summarized in an article by Baudran, a postdoc of mine, which was published in that ecography journal I referred to earlier. And I'm going to take some time to explain this figure. So each of these little rose diagrams or flower plots with petals represents an area, and we've looked at the change in the spatial occurrence of a number of species, and each petal represents a species. And the species are arranged such that the northern species are at 12 o'clock, and the southern species are at 6 o'clock, and then everything in between is a graduation of affinities for northern and southern areas. And then the colour of each petal is colour-coded in green according to whether the spatial occurrence of that species is increased or decreased in red. And we can see a few things as a result of that now. So if we look down in the southern area here, first of all, there are very few petals beyond 3 o'clock into the northern species, and that's what you'd expect. You'd expect the southern species to be in the southern areas, the northern species to be in the northern areas. But there aren't any northern species in the southern areas, as you'd expect. But conversely, in these northern areas, we have seen the occurrence of southern species appearing in the northern North Sea in particular, and over towards the Baltic. And those appearances are associated with an increase in the spatial occurrence, i.e. that these southern species are occurring more and more and occupying more space in these northern areas. And you can see that not only that, but some of the northern species are also expanding their range and changing in their spatial occurrence and increasing. And that basically tells us that these fish distributions are changing, and it's related to the climate, in that the southern species are finding a range of temperatures in particular that are more amenable to them in these northern areas than they used to be, and they're moving into them. And they are gradually moving north. This is a picture that is typical throughout the world. In the northern hemisphere, fish are moving north. In the southern hemisphere, fish are moving south, tracking the optimum temperature as global warming increases the temperature of our seas. Now, why is that important? Well, when we look at how quotas shares are being distributed around Europe, they've been fixed. for a long time. They've been fixed since 1983 under a principle called relative stability. So that means that the catch share for each member state in the European Union, is based on historic catches in 1973 to 1978, never mind 1980s when the policy came into place, but the policy itself was based on information from the catching sector in the 1970s. So as a result of that, each year scientists get together and they determine what the sustainable catch limit is for all of these stocks. And that catch limit then is broken down into national quotas according to relative stability. So a certain percentage of each stock goes to each country, and that percentage is fixed, same each year, even though the quantity changes obviously because it's a percentage, but it's based on the distribution of catches in the 1970s. And as you've seen, those distributions have changed. Now, an alternative way of determining what the quotas could be, what the catch shares should be, would be to base the percentage of how much is actually found now within national waters. And that's a concept known as zonal attachment, or ZA. And in its simplest form, it's simply the average biomass in A. So, for example, you can see now that the UK, once it has become an independent coastal state, will have this exclusive economic zone in red here on the right hand side, separate from Norwegian waters and separate from European waters. And what one could envisage is having the calculation of how much fish is in that particular area associated with the UK, comparing that with what's in Norway and the EU. And that's essentially what we've done. The only complication, of course, is that it's not as simple as just looking at the average percentage biomass in an area. There are other considerations that you have to bring into account, and we have considered those too. And they include the different life stages that occur, because a juvenile fish can occur in different places to the adults. So our formulation accounts for the proportions of any life stage. Is flexible in this equation here in looking at the proportion of any life stage. So that could be age, or it could be length, or it could be just juveniles and adults, as we'll see in an example in a minute. And then you have to weight that proportion by the amount of time spent in that area, because these fish migrate and move around. And it could be that the adults spend a certain proportion of their time in one area, then move and spend another in the other area. And so that needs to be accounted for as well. And then finally, you have to account for the fact that these different life stages have different weights. Juveniles are obviously much lighter than the adults and therefore will contribute less to the population. And so you weight the proportion by the mean weight as well. And there's details of this in the paper. But essentially, it just shows you that there are more considerations than just taking where the fish live. It's where they fish, where they live, when they are there, and what stage in life they are there. Now, in addition to that, we also have to think about the uncertainty of estimating where they are at any particular time, at any particular life stage. And for that, I've been using a geostatistical technique, which is a statistics branch that came from geology, which is particularly concerned with the use of space. And on here now we have a map of the three areas, UK, Norway and EU, that we considered. And I'm looking at the distribution of cod based on trawl surveys. And I'm using the statistics, this geostatistical technique, to estimate the uncertainty due to the sampling process and due to the fact that we look at different times of estimating the proportions of cod in the UK, Norway and EU. And the nice thing about this technique is that it's statistical, stochastic, and you can build up a distribution of estimates rather than just a point estimate of a percentage. And so, for example, on the right-hand side now, you can look at how the proportion, or the percentage in this case on the x-axis, is estimated in the various areas. And we end up with a distribution of estimates rather than a point estimate. And that's important for later, because we want to account for our uncertainty. Now, if we translate those distributions of percentage composition of the cod in the various areas, we can display them as box plots, and that summarizes the information quite nicely. And then we can then think about applying the same for juveniles as well as adults, because remember, our equation and our considerations separate those stages. And then we can estimate what our zonal attachment would be according to how long those particular stages spend in the various areas. And we can calculate the zonal attachment to compare it with the current situation, with the current quota proportions from that relative stability calculation. And what we find in the case of cod is that the amount in the area of the UK, according to zonal attachment, is higher than the current quota allocations, whereas the amount in the EU is the opposite, i.e. the amount of cod in European waters is much less than the current quota allocations. And always the same. Now, we found the same picture that we found for cod in many other stocks. We looked at the west of Scotland, for example, anglerfish, cod, haddock, hake, haddock, rockall haddock, saithe and whiting. And in just about every case, with the exception of rockall haddock, the amount of fish present in UK waters was much higher than currently allocated under the quota of relative stability. And conversely, the amount of fish available in European waters was much lower than the quotas currently given. And in all cases, these solid arrows indicate significance. And this is where the statistics come into play, because in the one case where it wasn't significant, that's the haddock up here, you might say that there's no significant difference between the quota allocations and the zonal attachment, and therefore that might not need any management intervention because they're essentially more or less the same. But in these other stocks where you've got solid arrows, the differences between them are significant. The same occurred in the North Sea, where in just about every case, the amount of quota allocated to the UK is less than the amount of fish in the area, accounting for different stages and the different times, with the exception of anglerfish. Anglerfish is the only stock where the UK gets allocated more quota than is actually fish in the area. Whereas in Europe, without exception, the amount of fish that they are given as quota is much higher than the amount of fish available in their waters. And this is the common complaint that fishermen have about the unfair allocation of fishery resources in UK EZs. And regardless of equitable arguments which one can make and the balance of the benefits of allocating quota compared to other things that you might trade that off against, one of the significant issues is demonstrated by looking at hake in particular. And I'm just going to finish with the example of hake, because hake is an extreme case. Okay, so when we looked at hake, current quota allocation in the North Sea is 18% allocated to the UK. Okay, however, before it gets allocated within the North Sea, the population of hake is split throughout the region from the Bay of Biscay right round the Celtic Seas and the North Sea and into the Kattegat and Skagerrak, approaching the Baltic. And the allocation is broken down by that zonation first. So actually, 3% of the total hake catch is allocated to the North Sea before the 18% is allocated to the UK. So the UK only gets 18% of 3%. So it gets 1% of the total hake catch. And why is that an issue? Well, if you look at how much hake is there now, according to these zonal attachment calculations, based on the recovery of that population and the flooding of hake into the North Sea, which incidentally is not unprecedented. Historically, we had a lot of hake in the North Sea. It was just overfished in the 50s and 60s and 70s. Anyway, now we have something like 48% of the total hake population in the North Sea. And as a result of that, if you think about how much the UK's allocation should be within the North Sea, our calculations suggest that they should get 58% of 48%, which is 28%. Now, why is that important? Well, because if these quota allocations are so far out of kilter with what's available, these hake are caught in a mixed fishery along with other species. And let's say, for example, you look at a year in 2011 where the quota of the UK was 348 tonnes. That's that 1% of total hake catch. There was a lot of hake in the North Sea. The fishermen would fish it and they ended up discarding it. So with a quota of 348 tonnes, the UK discards of hake in 2011 was almost 5,000 tonnes. If that had been allocated a quota according to zonal attachment, the total amount of 55,000 tonnes, 28% of that would have been 15,000 tonnes. And therefore, the UK would have had more than enough quota to prevent this practice of discarding. So that is an example of the problems created by having quotas that are totally historic and out of kilter with the current distributions of fish. And it causes problems with discarding, of which there's a landing obligation now, a discard ban, which is impossible to implement given these situations. So I come to my conclusions then. Fish distributions are changing, and that's for two reasons. First of all, we have a situation where stocks are recovering and the stocks are expanding, occupying greater areas. There's also environmental change, and fish are responding to warming seas by moving northwards by and large or into deeper waters, but certainly changing. We have an existing quota allocation mechanism that is completely out of date. It's based on catches in the 1970s when the situation was completely different. But we do have a system which could account for those changes by looking at the current distribution of fish. And this calculation that we've provided accounts for the spatial and temporal variability, as well as the life history and migration of the stocks. And if you apply that, you can see that by and large, the UK almost, not surprisingly, given its large area of sea with its exclusive economic zone, it has zonal attachment of UK stocks that would imply much greater quotas than it has at the moment. And without those quotas being enlarged, fishermen essentially can't avoid catch fish they have no quota for, and that causes huge discarding. The take-home message is simple. We currently use scientific evidence to set catch limits. We should also do that to set catch shares.